So welcome back, everybody. Let's start. So you see I have the questions lined up here. So here's what we are going to do. Please all stand up, all of those of you who want to play. On Zoom, please all raise your hands if you want to play. Let's look at the raised hands. Only one person on Zoom? You can raise your hand if you want to play. All right, then, to a second person. Okay, awesome. So all raise your hands. You still have a few minutes to do it. So I'm going to go through the questions one by one. You should have your smartphone ready or your laptop in order to answer the clicker questions. And every time I trust you because I have no way to check, so I trust you. If you get a question wrong, you should sit down and you remain standing if you got it right. And I'll ask the TAs every time also right when I give the solution. It's also based on trusts that you give me the collective answer that you discussed. And that's it. So we have on Zoom, we have more people now on Zoom, wonderful. And everybody else, feel free to raise your hand as well if you want to play. 5 people. All right. More people, yes, 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 wonderful. Okay. So, is everybody ready for the first question? Okay. So I'm not telling you there will be the same atmosphere as on television because I'm not an anchor, but we'll see. So this here is the first question. What is the main benefit of data independence? Is it answer A, that tables are fully uncorrelated with each other? Answer B, it is possible to change the physical layer while keeping the logical layer, which keeps the door large open for optimizations. Answer C, the data is fully disaggregated. Answer D, it prevents implementing support for a data shape on top of a system that was built for another data shape. So I give a bit more time for the first question, and then for the next ones, we'll start constraining the time. So now I'm just waiting for everybody to be able to answer. Still have answers incoming. Does anybody need more time? You can raise your hand in the lecture hall or write in the chat on Zoom. Was everybody able to participate? Yes, on Zoom too? You can write in the chat if you have any trouble. I'm assuming that now. So now I need to synchronize with the TA. You have an answer, right? Don't tell me just yet. We are going to synchronize that. So nobody's complaining in the chat, right? Everybody managed on Zoom. Okay. So I'm going to prepare to click this, and you should give me your answer exactly when I click the button, right? So 2, 1, 0. 2, yes, exactly. That's the correct answer, yes. Second and 2 is the same thing. All right, so we have 41 of you who answered correctly. The other answers are wrong. So tables fully uncorrelated, that is something else. I made that up. The data is disaggregated. That's the drill down of OLAP. That's something else. And prevents implementing support for a data shape on top of a system. No, that's the opposite, in fact, right? We saw you can even implement cubes on top of tables, right? So I trust you that you sit down if you got that wrong, and that's totally okay. I mean, we're in a university, we're here to learn. You can continue to play, you can continue to answer the questions all the way, and everybody else continues to stand. So let's go to the next one. Question number 2. What is the name of the standard model for querying tables? Is it the OLAP model, the QBIP model, the SQL model, or the relational model? And again, everybody can answer. Even if you're seated, you can also answer. You can participate to all the questions. All right, let's cap it at 1 minute, 10 more seconds. Please let us know if you have any trouble and you're standing and you don't manage to answer. Are you ready to give me an answer? 2, 1. Yes, 4, the relational model. SQL is the language, right? SQL is the language. It's the relational model. We have the relational algebra, that is what we can do with it, and so on. All right. Well, we need a winner at the end, right? If you all answer everything until the end, then we don't have any winner, and I'll have to separate the chocolate into 40 pieces. So, all right. So congratulations to those of you who got it right. And on Zoom, yes, I see some of you also got it right. Wonderful. Let's continue then. Now we have, which one of the following is not a relational algebra construct? Is it dicing, selection, projection, or join? One of these is not a relational algebra construct. It might exist, but it's not in the relational algebra. Right? I continue to cap it at 1 minute, right? I give you 1 minute every time. And of course, everybody can continue to answer on the clicker app, even if you're seated. 15 more seconds. Is the TA team ready to give me an answer? Okay. Then in 5, 4, 3, 2, 1. 1, the first one, yes. First and 1 is the same. By the way, do you have the cube, or you can speak also in the cube for people to hear you on Zoom? All right. So yes, it's the dicing, because the dicing is, say it all at the same time, is for cubes. Yes, exactly. Dicing is for cubes. It's not in the relational algebra. Join is, you can join multiple tables in the relational algebra. Okay, let's move to the next one. What does SQL support? DDL and DML, DDL only, DML only, or neither DDL nor DML? Is the TA team standing ready to give an answer?
Yes.
Okay. So in 15, 10, 5, 4, 3, 2, 1.
One.
Yes. Both data definition language and data manipulation. Data definition, that's create table, alter table, and so on, that's DDL. And DML, it's insert values and it select from where, that's DML. So it has all of that. Okay. Okay, now it's starting to converge slowly. All right, let me get to the next question, which is the following. Which adjectives characterize SQL? Functional, imperative, declarative, set-based. Multiple answers possible. You only need? Okay, let's do it democratically. Who would like to require to get everything right? Who would like to require that one is enough? We have a majority, so we'll do one is enough. Okay. You can play it safe, yes. 20 seconds. Does the TAs need everything? Ten more seconds.
Only one answer, right?
Who wants the TAs to give one answer only, or who wants all of them? All of them? Okay, can I tell them how many are correct? Yes, okay, 3 are correct. Go ahead. Oh. That's right. So were they? Oh, let's trust the TA. Did you have this in mind? Exactly those. Yes. Okay. Who believes the TAs? We believe them, right? I believe them. I believe them. Okay. So functional, declarative, and set-based. Imperative, no, because imperative, that's what I told you, is when you give the instructions to the computer of what to do. But that's what you do in C++ or Java when you implement the system. But SQL is not imperative. All right? It's functional, declarative, and set-based. Set-based because it manipulates sets of records at the same time. Declarative because you say, this is what I want to do. And functional because mathematically and formally, it's basically a cascade of function calls, like the query plan. Here is another question. What is the first normal form? The first answer is, it requires that the left-hand side of any non-trivial functional dependency is a superkey. Second answer, it is a constraint requiring for values in a table to be atomic. Third answer, it requires identical support for all tuples in the same table. Fourth answer, it requires that the values in a column are part of the same domain. There's only one answer in here. Fifteen more seconds. Do you need more time for that one? 30 only? Who needs more time? I think we can just wrap up then. Are you standing by to give the answer?
Yes.
All right. Yes. 2, 1, 2. 2, yes. It is a constraint requiring for values in a table to be atomic. No table in a table in a table in a table in a table, like the Inception movie, a dream in a dream in a dream. We do not allow that in the first normal form, only atomic values. It's flat. Okay, so we have, how many do we have in the room? We have 1, 2, 3, 4, 5, 6, 7. No, I have trouble counting. 1, 2, 3, 4, 5, 6, 7, 8, 9 people. You're also standing, 9 people. And on Zoom, we have 2 people. So we have 11 of you who are still in the competition, right? And the TAs. So we haven't determined yet if the students wins or the students win or the TAs win. So let's go to the next question. Oh, this one, do you want it now? It's a complicated one. Do you want to postpone it a bit or do you want it now? Who wants it now? Who would like to postpone it? Oh, that's a tie. Oh, the TA, okay, the TA is, okay. Let's, but not for long, right? Just a little bit, I'll come back to it. What is a functional dependency? It requires that the domain depends functionally on the attribute name, or it expresses that some attributes stochastically depend on some other attributes following the Markov law. or it's a law that requires that the dimensions in the no-lab cube uniquely identify a cell, or it expresses that some attributes deterministically depend on some other attributes. There's only one answer possible. It has to be the definition of the functional dependency. Twenty more seconds. It's funny because when I stop talking, the microphone sounds kind of disconnects. Is the TA team ready to give an answer? Okay. 3, 2, 1.
4.
Yes, you got it right. Yeah. Oh, wow. Majority, almost everybody. So yes, it's when some values in some columns determine the values in some other columns. The third one would basically mean that there is a functional dependency, of course, in a fact table from the dimension values to the value in the last column. But in that case, it even means that it's a super key. This is what it actually means. So this is why it's the fourth answer that is correct. The second one is absolutely totally made up. I never mentioned the Markov law in the lecture. And the first one, well, if you have the domain integrity, then obviously the domain depends on the attribute, but that's not what a functional dependency is. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8, and on Zoom, 8, 9. 9 of you are still in the contests. Serializable schedule. How can you see that a schedule is serializable? There is a cycle in the graph of the transactions, there's a cycle in the graph of the queries, there's a no cycle in the graph of the queries, or there are no cycles in the graph of the transactions. Remember that a transaction is made of multiple queries. We call them Alice, Bob, and so on. And then inside there's the individual queries. So we've seen graphs with the queries and graphs with the transactions, right? So how can you see that a schedule is serializable? Is the TA team ready?
Yes, yes.
So 5, 4, 3, 2, 1.
4.
Yes, indeed, there are no cycles in the graph of the transactions. Serializable means that you can disentangle the whole spaghetti, and that's only possible if there are no cycles in the transactions. Like you can put the transactions in a specific order. The queries, the graph of the queries, this one never has a cycle because it always goes from the past to the future, right? All of these rows. You really have to merge the queries belonging to the same transaction into a single node to get the graph of transactions to test for serializability. 1, 2, 3, 4, 5, 6, 7, 8, 9 people still in the game, and the TAs. I think in previous years, the TAs already lost at that point.
It's because we postponed.
You're doing well. Yeah, I can postpone except if the students start requesting that I ask it. Do you want me to ask the second normal form? Boy's code? Boy's code or second? Let me go to Boy's code then, and then I'll ask the second one. Okay, Boy's code. Is it always possible to turn the data in a table into Boy's code normal form? When I say table, I assume first normal form, at least in that table. Can we always turn the data into Boy's code normal form? No. Yes, by iteratively decomposing it into overlapping tables based on functional dependencies that break the rule that the left must be a super key. Yes, by iteratively decomposing it into disjoint tables based on functional dependencies that break the rule that the left may be a super key. My grammar suffered a little bit here. Or yes, by iteratively decomposing it into tables partitioned by sets of rows based on functional dependencies that break the rule that the left must be a super key. Might need a bit more time here. 25. Did everybody have a chance to answer? Also, everybody standing up could answer? Yeah, okay. So let's go and ask the TA team then. Are you ready? So 4, 3, 2, 1. Yes, the second one. So the key part, I gave you the algorithm, right? It's overlapping. Remember that when you have a functional dependency that breaks the rule, you take the transitive closure of what's on the left. This part must be in both tables on both sides. It must be overlapping. You need to join them back, remember? If you don't have any overlap, you cannot join back. You would have the Cartesian product. In order to join back, you do need an overlap for the join. And partition by sets of rows, that's something completely different. We actually do it in big data in order to distribute over machines, but that's not the Boyce code normal form. Okay? 1, 2, 3, 4 of you are still standing in the lecture hall, and we still have also a 5th person on Zoom. Well, second normal form. You need to cheer with second normal form, second normal form. Right. Okay. Yes, I did hear some cheer. Okay, let's do it. Let's do it. What is the second normal form? It is answer A, an attribute that is not in any candidate key cannot depend an attribute that is not in any candidate key cannot depend on a strict subset of any candidate key. Or answer B, attributes cannot depend indirectly by transition from a candidate key. Or answer 3, values must be in superatomized form, no strings, characters only. And 3, the data must form a full dense cube. Do the TAs have an answer?
We guess an answer.
You guessed an answer. Okay. You need more time? Yeah. Is it okay now? Okay, so I'm going to ask the TAs for the answer and to reveal it. I hope we do have at least one survivor. Are you ready? Sorry?
Just 5 more seconds.
5 more seconds. Okay, okay. Technically, I was about to count down from 5, so. So, you're ready. 5, 4, 3, 2, 1. Yes. So we have 3 survivors in the room and 1 on Zoom. So another way of putting it is that a non-prime attribute, an attribute that's not in any candidate key, a non-prime attribute cannot depend on a strict subset of any candidate key. The third normal form would be that a non-prime attribute cannot depend on something that's not a super key. That's even stronger. And in fact, the second one is an alternate formulation of the third normal form, but not the second. Values must be in superatomized form. That I have no idea what that is. I just made it up. And the data must form a full dense cube. this in essence would be a higher normal form. There are higher normal forms that kind of model that, but this is more than 3. All right, so we have 4 of you still in the game. I was hoping that that question might actually break ties. So it did it partially. You're really good. This is very impressive that so many of you got that one right. In the exam, I have no intention of asking you about the second and third normal form, just to be clear. I just mentioned them saying that they exist, but the Boyce code normal form, that is in the exam, in the first one. All right, then we have this one. How is the data read from disk in a relational database system? In blocks, bit by bit, file by file, or table by table? Is the TA team ready?
Yeah, it's like a
Yeah?
Yeah.
Then let's see.
Yes. Yeah.
5,
Yes.
4, 3, 2, 1, and
One. Yes.
1. Okay.
I mean, we said
What I thought. Okay. In blocks, yes, that's what I told you in the first hour, right? Bit by bit would be incredibly inefficient. You can come back in a year if you want to read a table bit by bit, especially on a mechanical disk. File by file, no, the files, they can be 1 gigabyte, right? I told you these chunks. They are 1 gigabyte, that would be too large. And table by table, a table can be a terabyte. So this is even higher. So it's block by block, and that both applies for reading the data and for reading an index. Hello, good to have you here. So let's go to the next one. How can you tell that a facts table, remember that's holding the data of a cube, that a facts table is denormalized? Each dimension corresponds to exactly 1 column. That's what it means that it's denormalized. Or there is a dimension corresponding to multiple columns that relate to each other with functional dependencies. Or answer number 3, there are several measure columns. Or there is only 1 measure column. A denormalized fact table. Typically, when we say denormalize, it's very, at least in the context of big data, it typically means that it's not in a higher normal form. So it's technically not in the Boyce code normal form, typically. You can also denormalize it all the way that it's not even in the first one. But technically, a table that is in the first normal form, but not in Boyce code, that would also be considered already denormalized because it's not in the higher, just so that it's clear for the question. Do the TAs have an answer? The TAs have an answer. Do you have an answer, all of you? Yes? Okay, and on Zoom too, you have an answer? I assume so. Maybe you can check the chat. Chats, just to confirm that we don't miss you in the answers. All right, so 5, 4, 3, 2. Yes, the second one, indeed. There's functional dependencies. If you join back with the satellite tables, then it's going to add columns. So a dimension will end up with multiple columns, and you do have then functional dependencies in there, and that breaks the Boyce code normal form. Several measure columns or only 1 measure column, that doesn't change anything. You still have the functional dependencies from the dimensions to the measure columns, but that doesn't affect the fact that it's denormalized or not. All right, so that was the second answer. We have 2 survivors in the room, and on Zoom, oh, we lost also a student on Zoom. So it's the 2 of you. You will definitely get chocolate because you're in the lecture hall. Let's continue. Then it's impressive because the TA team is still here. What feature is enabled with a limit and offset in SQL? Is it joining tables, paginating results, projecting a count, or controlling the internal data flow? Did you both answer? Yes? Okay. Does the TA team have an answer? Okay. And I think I read it on your lips. We'll see if it's correct. 4, 3, 2, 1. Yes, exactly. Paginating results. Because with limit offset, you can say, for example, offset 10, limit 10. It means pages 11 to 20, results 11 to 20. That's how you get search engine results. All right. It's very useful, by the way, at the exam. If you don't want to output too much data, then don't hesitate to use limits in order to get quicker results when you play with a query. All right. We still have everybody here. It's going to be tough to actually break the tie now. And I already used my second normal form question. So which of the following are indices? Table indices, block indices, hash indices, B+3 indices. On this one, you have 30 seconds, starting to also reduce the time. 20 seconds. 15. You need everything correct. 10. Do you have an answer, the TAs? 5, 4, 3, 2, 1, and 3 and 4. Yes, exactly. And you're still here too. Wow, you're excellent. Hash and B+3, block indices and table indices, I made that up. All right. What is the difference between a database and a database management system? Is it that a database provides data independence while a database management system might not be data independent? Or is it the same? Or is it that a database management system is the data itself and the database is the software that is used to manage how the data is stored into queries? Or the database is the data itself and the database management system is the software that is used to manage how the data is stored and to query it? You have an answer? Yes? Okay, the TAs too. So 5, 4, 3, 2, 1, and 4. Yeah. Oh, wow. This is wonderful. I love that. Okay. So indeed, the database is the data and the database management system is the software. A lot of people get that wrong. You wouldn't believe if you read in social media the confusion between the two. Is SQL enough to slice and dice a cube into a cross-tabulated view? Yes. No, it can slice but not dice. No, it can dice but not slice. And no, because it cannot be used to roll up a necessary step to slice and dice. You know? Mm-hmm. You haven't entered? Yes? Okay. So 5, 4, 3, 2, 1, and 2. Yes, it can slice, but not dice. SQL is totally unable to dice. MTX can, because in the select clause, you can say on column, on row, but SQL cannot dice. I try to make you remember that by telling you, try to ask your cat to cook its own food. That's basically the same thing. All right. But now I need a winner. So which of the following are Armstrong actions? Reflexivity, augmentation, transitivity, or composition? Augmentation for the second one, obviously. So we'll see if there is a tie or neither gets everything right or everything wrong, we'll just count the number of correct results that you have. Maybe that's going to help break a tie. Otherwise, you'll share the chocolates. We'll have two winners. Do the TAs know? The TAs know.
We don't know.
You don't know. Did you guess? Okay. Did you answer your answer? Yes? Yes? So the TAs will give their answer in 5, 4, 3, 2, 1, and yes. Did you get it right? How much did you get right? 2 and 3, and you? All 3. We have a winner. Applause. What is your name, your first name? Nico. Yeah, congratulations. Oh, first, congratulations like this.
Thank you.
And you get all of that chocolates. Like this. This is all for you. And the TAs also got all 3, right? You can. I have to motivate the students for the exam, right? Yeah. So it's impressive because this year the TAs and the students were on a tie. It's the first time that it happens. We never had that before. It's always either the students or the TAs. So yes, so now comes the emotional part. I'm super sad that it's the end, and it was a really awesome class. We participated a lot. It was really a pleasure. I think it was also a pleasure for the TA team to have you with us. The good news is that it's not over because there's still an exam. But we'll still help you. So, of course, we'll take a bit of vacation, the TAs too, but then we'll be monitoring the Moodle forum. You can send us emails if you don't understand something. So I really encourage you to interact on the Moodle forum and or on the Element chat, right? If you're not in the Element chat, you can also ask us, but you do have these 2 places that allow you to interact and to interact with us. Do not leave questions unanswered. If you have a doubt, if you don't understand something, really reach out to us. We will be here to help. Typically, there is a rush of questions a week before the exam, and typically we try to answer everything until 48 hours before the exam. Then in the last minute, it's a bit less guaranteed because then we might be overwhelmed with questions, right? But really, we are here for you. The exam is not a competition. It's not about a ranking. It's about performance assessments. So I'm happy if as many of you as possible pass. I mean, this is what any teacher would hope, right? So with this, thank you very much for being such an awesome class. Thank you to the TAs for being awesome TAs. And maybe I'll see you in Big Data for Engineers next semester. Thank you very much. Thank you. Oh, that was long. Thank you. I really appreciate this. Thank you.